Hi everyone, in this video we are going to talk about JWT, which is JSON Web Token. It's an open standard to define a way for securely transforming the information between two entities. When we talk about the data security, that means whatever information is being transferred from one entity to another, that is shared in a secure way. There are two parts of it. One, whatever data is being transferred, no one else can identify that information. Second thing is, if that data is being transferred, there should not be any entity who is going to make changes in the data before it is reaching to the actual party where it need to go. Here we have two type of token. One is JWS and another one is JWE. JWS is JSON Web Signature and JWE is JSON Web Encryption. If we want to ensure that whatever information is being transferred from app 1 to app 2 should not be visible anywhere, in that case JWE is used. And when we want to be sure that the data is not being tampered, then we can use the JWS, JSON Web Signature. In this particular video, we are going to talk about JWS and we will refer it as JWT. There are different parts of the data that will be sent in the JWT token. Here we have the header, we have the claim and the signature. Header is the part which will define the algorithm which is used to sign the data. And then we have the claim. It provides the actual data that need to be transferred from entities. Header and claim, these parts are the encoded values. They are not going to be encrypted. Whatever information is there within the header and the claim, this information will be signed with the help of some key. It could be the secret key when we are talking about the symmetric hashing, and there can be a public and private key combinations. So it will be signed with the help of private key in case of asymmetric hashing. This value is the signature. So this information is created in the form of token, which is a.b.c. So here we have the header part, which is encoded. Then we have the payload, which is the claim that is encoded. And the third part is the signature. Whenever token will be sent to the app 2, there is a responsibility of app 2 to ensure that the token is not being tampered. So app 2 need to verify whether the token is valid in its structure, and then it has a valid signature. Then it can look up to other information of the claim, which is the expiry of token, the issuer or the client information. If it has additional information within the claim, then it will check for those all values, and based on that it will identify whether the token is valid or not. We can use this JWT token in case of the authorizations. Once a user is authenticated with the help of auth server will generate a JWT token that will contain the information of the user. With the help of those information, some action can be taken on the client side. So this information can be part of the JWT. For example, if we are talking about certain roles for a user, if user has a specific role, then only user is allowed to do certain operations. In that case, we can get that information within the claim in the form of roles or groups or permissions, etc. The main thing to note is whatever information we are keeping within the claim or the payload is not encrypted. In this particular encoded payload part, it can be decoded. We have to keep in mind that whatever information we are keeping is not the secure information of a user. For example, password, personal information, etc. To generate the signature and to verify, there are different libraries in different programming languages. We will be using the Nimbus library, and we will see how we can use that library to generate the JWT token and to verify it in the Java code. Let's get started. Here I have the Java code, and in the build.gradle file, I have added the Nimbus library. With the help of this library, we will get some methods or classes which are required to generate the JWT token and also to verify it. For this purpose, I have created one class JWT token verifier, and here I have two methods, verify token with secret and verify token with public key. Whenever a token is signed with the help of secret key, then how we can verify that. And in the second example, we will be using the public key to verify the token. And here I have the test cases. We will be writing the code for the JWT token verifier. Whatever token we will pass to it, with the help of secret key, we should be able to verify the token, and same goes for the public key example as well. We need to generate the token. Token contains the information of the header, payload, which is called claim, and the signature. To generate the token, we can use the Nimbus libraries class sign JWT. It has a couple of constructors. We are going to use one which takes the header and the claim set. Header contains the information of the algorithm and the type of the token. For header, we have the class JWS header, which takes the algorithm. And this class is again coming from the Nimbus. For the algorithm, there are different kind of algorithm. For the asymmetric one, we can use the RS256. For the symmetric one, we can use the HS256. So let's use the HS256. This is the header, and now we need to provide the claim set. For the claim set, Nimbus library has provided the JWT claim set class, and here we can use the builder, and eventually the build method will give us the JWS claim set. Within this builder, we can add the different properties that we want to set within the claim. So I'll take it out as a variable and we will set the values here. Now for this example, I want to set these values. So this is the issuer who is issuing these token. For example, we are using the test.com. Similarly, the client, the test audience, and then with the claim, we want to add the role, admin role. We will also set the expiry time. For setting the values, here we have the builder, and within the builder, we can use the methods available within the claim set builder. Here we have the expiration time, audience, issuer, issue time, JWT ID, subject, etc. These are the methods we can use to set the values within the claim set. And if we need to add the custom values, we can use this claim method that takes the name and the object, which can be used to provide any kind of value to our claim set. Here, let's add the values within the builder. So first thing is the issuer, and I have got the issuer as test.com. Let's add the audience, which is the test odd. Here we can set the expiration time, and let's keep the expiration time as 10 seconds later than the time now. So here, new date, get time plus 10 seconds to it. This expiration time takes the date, so we will create a new date and let's pass this value. We can also set the claims. Here I have got the claim as role and the value is the admin. So we have got this builder and the claim set we are getting over here. So we have got the claim set and the header. Now let's see what is the value of the signed JWT. I'm going to debug this. So here we have got the signed JWT. It has a couple of values set. Claim set, that is what we have passed in the input. And then we have the header. And it has got one input value, which is signing input string. Here you can see it has two parts. First part, which is the encoded value, and the second part, which is again the encoded value. This is the encoded value of the header and the claim set that we have provided. Now, if I just copy value and let's go to the base64 decoder, and here you can see we have got the first part and the second part. If I just remove the first part here, and we have got the complete claim set. The JWT token also have one more part, which is the signature part, the final part, but at the moment it has a null value. We need to generate a signature for this signed JWT instance. For that purpose, we can generate the sign with the help of sign method, and here we have the sign. Now we need to provide a signer who is going to sign this. For the symmetric algorithm, we can use the MAC signer, and here we have the new MAC signer. It takes a secret value, so the same secret will be shared between the client and the server. While generating the token, we are using the secret as secret key. Now, if I just debug it again, look at the signed JWT. So you can see here we have the signature as well, and then we have this signing input string. Now, if I just copy the value of the signature, go to this base64 decoder, it's not an encoded value. No one can get information out of this value. If we need to get the complete token out of it, we can use this serialized method of the signed JWT, and here it is going to give us the value of the token. Here we have the token, which first part is the encoded header, second part is the encoded payload or claim set, And the third part is the signature. Now we need to verify this token within our verified token with secret method. So for the symmetric key, we need to have the same key, and here we are passing the secret key and the token that we have got here. For verifying the token within the Nimbus library, we have JWT processor, which is going to process the token that we have got in the input. So for that, we are going to create an instance of the JWT processor. So I have default JWT processor. It has a couple of constructors. Now I'm going to use the default one. To verify the token, we can use the process method of the JWT processor. Processor.process, and it requires the token that need to be validated and then the security context. We don't need the security context at the moment, so we can pass null value here. I'm going to pass the token that we have got in the input token, and the context is null. This method returns the JWT claim set. Whatever claim set we will get from this particular token will be the values which we have passed in the test case. Based on the configuration within the client application, that claim set can be verified. Now here it throws exceptions. I'm going to surround them with a try catch, and it has the pass exception if the token is not in the correct format. Then we have the bad jaws exception if the token is expired or it is missing certain kind of claims, etc. We will handle all of the exception in the same way for now. So I'm going to use the exception over here, right? So let's remove all of these. You can handle it according to your requirement, but for the simplicity, I'm just using the value as false for now. And to print the failure, we can add here. Here we can add the region get message. If we just run this particular test now, signed JWT rejected, no JWS key selector is configured. To verify the token, we need to provide the key. With the processor, we can set couple of things. First thing is the key selector. So I'm going to set the JWT key selector. Within the key selector, we can set the key that was used to sign the token so that we can regenerate the hash and we can validate it. JWT library provides the key selector, single key JWS selector. It takes the algorithm and then the key. Algorithm is again going to be the same algorithm that we have used here in the test case, HS256 algorithm. And then it takes the key. So we need to create a key, and again I'm going to use the same key as new MAC signer dot get secret key, and here we need to provide the secret, and this is the secret key token. And now if I run this, expected true, actual false, but it did not print anything. That means it has reached here, and in final case we can return true. Let me keep the claim set as a global variable. Rerun this. We have got the claim set, and these claims are whatever claim we have set in the token. So all of them we are able to get it, and manually we can verify the values in it. In the configuration, we can provide the issuer, audience, role, etc. for the specific token. If those are not matching, then we can mark that as validation failure. Instead of writing the code ourselves, we can use the verifier method of the process. Here we have the set JWT claim set verifiers. We can verify the claim set here. We can define a new default JWT claim verifier. It has couple of implementation. It takes the exact match claims. Whatever claim we have got in the input, if those values are not matching, then it will fail. And the required claims are the claim which need to be part of the token. If those are missing in the token, then it will fail. First of all, we need to provide the claims. Within this, we can apply the claim set the same way as we have created the claim over here in the test case. We have the issuer, audience, expiration time we can remove because this is the value that will be validated. And then we have the claim, and it has a value admin. For now, I'm using this claim set, and then we will change it accordingly. We also need to provide the list of claims which need to be part of the token. Here I have the asset, and let's provide the role, and we have the issuer and the audience that need to be part of the token. If it is not there, then it should fail. JWT claim set names dot audience Similarly, issuer, and also the expiration time as well. Here we are expecting that we should have the audience, issuer, and expiration time within our token. If any of them are missing, then it will fail. And similarly, the role. Now let's do one thing. Firstly, run this, and it is successful. Now remove the role and let's run this. It's failing and it says JWT missing required claims role. If that will not be added into the token, it will fail. Same goes for any of the field. For example, if I have this expiration time, I'm removing this, it is failing for the expiration time. If I remove that particular thing from here, expiration time, and here it is working. Whatever information you will add within the verifier, accordingly it will validate the token. A couple of things we need to keep in mind. For example, here we have the claim and I'm passing the role, and if there are multiple values in it, this claim takes an object. We have the values, say admin1. If I just run this, it is failing and said JWT role claim has value admin, must be admin and admin1. In this case, you can see we are passing the role as admin. It is possible that for some of the user there is only one role, for some there are multiple roles. In that case, we cannot verify them by the way we have verified over here. However, we can do that verification within the claim set. So here we can check from the claim set dot get claims. Here we are going to get the roles. We have got these roles, and now we can check whether these roles are part of any of the role which is defined in the configuration. Same goes for the audience as well. So there can be multiple audience. There is another implementation. We can pass the multiple audience, and even if we have a single audience in the input, it will be validated. This audience is going to be removed from here, and now we have passed the audience in here. So in this case, it is successful. And if I change this value to say 3, then it will be failing. This is the first part wherein we have validated the token with the help of secret key. In the same way, we can validate the token with the help of public key. And for the public key, we can generate the public key with the help of RSA key generator. And here we have got the key. This key has two parts, the private key and the public key. Private key can be used to generate the token, and the public key will be used to validate the token. I'm going to copy these. So instead of the MAC signer now, we need to sign this with the help of RS256 algorithm. And for that, here instead of MAC signer, we will use the RSA signer. And it takes the key, which is the key that we have. Here we have just changed the RSA signer. And now here we have got the public key. Within the token verification, we can again use the same default JWT verifier. I'll copy all the things from here. There are a couple of changes now. As we have got the public key, here we cannot use the single key JWS key selector. Here we have got the JWS key selector. It returns the key. We need to pass the public key to it. I'm going to use the collection dot singleton list, and whatever key we have got here, we will return that key from here. It can be converted into the lambda. So here I have got the key selector as the public key. There can be a possibility that we have got the key in the auth server URL, or we have the key available within the file. Then also we can use the key selector, and for that purpose we can use the JWK source builder. And here we have a couple of methods. We can use the create method, which is going to take a URL, and you can pass the new URL of your authentication server URL of the public key. Or if you have the file, you can just pass the file stream here in the URL, and you will be able to get a key source. And now within the JWS key selector, we can set the key source as well. Processor.set key selector. Here we have the JWS verification key selector, and now you can pass the key source to it. And for algorithm, obviously we have the RSA 256 algorithm. If you have URL or you have file path, you can just apply this particular way. Now I'm going to remove this as we are using public key, and now we have got the implementation here. If we just run the token verifier, now we are able to validate the token with the help of public key as well. Here are the two ways in which you can generate and verify the token. So this is all about this video. I hope you like it. Thanks for watching and happy coding.